Okay.
Okay, last presentation of the day and of the workshop. Well, thank you. Yeah, the survivors. I'll try to make it pain. So what I'm going to present today is a paper co-authored with Gustavo Pereira Serra from São Paulo State University. I'm Ettore Gallo from the University of Parma. And the title is Climate Change Mitigation and Green Energy Investment, a Stock-Flow Consistent Model. So yet another ecological SFC. This is actually a published paper, recently published in Ecological Economics. Still, I think it's worth presenting it as we are planning to expand it and make it probably more realistic and more complex. Well, on the motivation, I probably don't need to spend time. What we try to do in the paper is really to provide a simple framework to capture the feedback between distribution, demand, accumulation, and emission, and the environmental dimension of the model. We do so by writing down a small to medium scale SFC model with ecological constraints, some key features of the model with a Goodwin type profit squeeze mechanism. And essentially the model is a two-factor model where it works in the energy and the non-energy sector. And we also look at the government role in speeding up the low carbon. Some of the key questions that we try to answer are, first, how does the pace of the energy transition influence economic outcomes and emissions trajectories? A broader question also is if climate change mitigation can be achieved without the growth scenario, and also kind of broad question: what are the distributional implications of different financing mechanisms? So a preview of some main. Oh, that was my bad. I slightly moved the computer. No, I think it's okay. So what we showed is a preview of the main findings is first that we show that negative shocks to the green energy, to the green investment share slows down the transition and depresses aggregate demand. The fiscal policy can simultaneously stimulate the economy, the macroeconomy, and reduce emissions. And we look at the effect of progressive taxation, in particular, the model. We find that, well, the model shows that progressive taxation, meaning a higher 20-year taxes compared to workers, to taxes on workers' income, is compatible with emissions reduction. And we look into the conditions for the government to be effective in achieving net zero emissions. So important disclaimer: the model is a business cycle model, so meaning that we detrend all the relevant variables by a deterministic growth trend that can be demand-driven, supply-driven. We don't actually deal with long-run growth. We only look at the demand side, determination of the short run of the business cycle. Also, for coding purposes, the model is coded in Dinar, which in a way is also relevant for the workshop is empirical SFC. I think that Dinar is a great avenue for empirical testing of SFC models because it allows to have a very comparable framework with DSG models, and we only run theoretical simulations. But if you feed the data into the program, then you can run a Bayesian estimation, for instance. This is the paper structure. I'm going to spare you the literature review. going quickly through the model, the building blocks of the model, and show you some simulation results before moving to policy implications and conclusion. So these are the agents. The model, we firms operating in the energy sector and firms operating in the non-energy sector. Households are workers, are either workers or rentiers. Workers consume their entire wage income net of taxes. So we have no worker saving, while rentiers save a fraction as are their income that is partly profit transferred to them and partly. In the financial system, we have a central bank that operates following a Taylor rule. It sets the discount rate based on a Taylor rule, and commercial banks that create credit, marking up the discount rate by the central bank. An important assumption is that we assume the government to run a balanced budget. This is not really MMT. I mean, it's not really what most people would suggest as a policy implication, but we do so because we want to show that even with a balanced budget, the demand side determination of output over the short run allows for the government to be able to speed up the transition. So the government budget is equal to taxation. The tax that it receives from worker household and rentiers, with two different tax rates on workers' income and rentiers' income. Production in the energy sector is entirely the only output, the only input in the energy sector is capital. So the energy sector operates with no labor requirement, which I'll say it's fairly realistic, as energy sectors tend to be way more capital than labor intensive. And the capacity, there is a capacity utilization adjustment. Energy firms do not really need, do not or necessarily not usually operate at full capacity. For the sake of simplicity, we assume that the accumulation rate in the two sectors is the same. So investment in the investment rate in the energy sector aligns with the investment rate in the non-energy sector. And the changes in the debt balance are entirely determined by a portion of the investment that is debt financed. So firms partly finance investment by giving debts for a fraction C, I think it's around there in the model, and partly the rest is financed by via retained earnings. And also we don't have debt amortization, so new debt is contracted only to finance new investment. So this is essentially the fraction that is debt finance, and then if debt service is subtracted from the profits of the firm. This applies both for energy and non-energy firms. Then in the non-energy sector, we have a more slightly more complex production function, as firms in the non-energy sector produce using three: physical capital, labor, and energy. Output in this sector is demand driven, so a change in demand will produce an increase in production. And then something that I'm not going to present you is the basis of, firms set prices following a cost plus pricing. And the mechanism for debt is the same as I showed you before for energy firms. Crucial equation in the model is the investment fund for the non-energy firms. So we have a rather ugly investment function in which investment for non-energy firms depend on expected sales that are proxied by lagged sales. The denominator is always the steady state value. So here you see expect the steady state with a certain elasticity. So the investment depends on sales, debt, the financial cost of servicing this debt, the unit labor cost, and another term that captures the emission flows. So this is the last element is crucial because it captures the feedback, one of the feedbacks that goes from the environmental side to the economic side. If emissions increase, then firms will tend to, this will penalize by a certain activity the investment of firms in the non-energy sector. Now, these are the crucial aspects of the economic module, let's say, of the model. Then we model the transition in a pretty simple way by taking let's say, a sympathetic and also Goodwinian approach by saying that in the energy sector, firms in the energy sector gradually increase their reinvestment share to a logistic transition, to a logistic diffusion process. So the green innovation in the energy sector starts slowly, then at some point accelerates up to a plateau in correspondence of a maximum value of the green investment share. And this maximum value is associated with net zero emissions. Now, this process is not entirely, well, it doesn't come from the sky, it doesn't come from the sky, but it can be influenced by mitigation expenditures from the government. So the government can play a role in affecting the growth rate of the logistic function, essentially. And we take a very simple approach by assuming a linear effect, meaning that if the government spends more on government increases mitigation expenditures, this will speed up the growth rate of the logistic function. It will allow the economy to transition faster to a situation in which the green investment share is at its maximum. In an appendix of the paper, we also conduct some model sensitivity by modifying this functional form with a non-linear specification, and the qualitative results do not change. Emission generation, so the change in the flow, of emissions depend on production, so in line with the empirical evidence, Co and co-authors of 18 and 22. Emissions are procyclical over the business cycle. There is pretty strong empirical evidence of this, and this is captured by this specification. Total productivity, then emission will also increase via a certain sensitivity. And at the same time, the plateau of the green investment share, as the economy transitions to a green economy, the gap between the maximum and the actual green investment share closes, and this will reduce the flow of emissions. The last, the closure is the good. There are some other elements that I'm not gonna I'll skip for the sake of time, as we have well, we have a conflicting claim mechanism, some distributional conflict in the labor market. The important aspect to bear in mind is that the bargaining power of workers varies according to labor market conditions, in line with a Goodwin type analysis. So this is our model flow chart. In the central bank sets the interest rate that is marked, and commercial banks give credits to energy and non-energy firms according. And if you if we zoom on the emissions part, you see that well, the government can affect the transition by speeding up the transition to alpha max, to the maximum green investment share, while and also well, the goods market affects emission by the parameter CON that captures the procyclicality of emissions to and production over the business cycle. And then there is a feedback effect going from emissions to the investment of non-energy firms, as the you know, the link here will be temperatures, even though these are not explicitly modeled, but as climate change accelerates, this will depress investment of non-energy firm by a certain sensitivity. Oops. So the model is, in its structure, is essentially, well, the way we conduct the simulation is similar to the ESG counterpart, meaning that we conduct a series of random one standard deviation shocks to some variables of interest. Just to show you the reason behind the structure of the model, if we do a positive shock to non-energy investment, you will see that positive investment shock generates a standard demand-led expansion over the business cycle, with aggregate demand rising, that boosts investment in both energy and non-energy sectors, as well as employment, consumption, wages, inflation. Then destabilizes the central bank that intervenes by increasing the interest rate in line with the Taylor rule behavior. And the economy gradually returns to the steady state configuration. An aspect that I'm going to later is that higher tax rate on rate years is always expansion. And the fundamental reason is that the government propensity to spend tax revenues is always higher than the rentier's propensity to consume. Whenever the government receives one additional euro or dollar, it will increase spending. The rentiers will not. So the balanced budget fiscal expenditure stimulates aggregate demand, and so in general, if we tax rentiers in the model, we'll get demand expansion. Instead, if we tax more workers, we'll get a neutral effect on aggregate economic activity, because, well, the only thing that happens is that because of the assumption of a balanced budget, higher wage tax will simply reallocate spending from workers' consumption to government expenditure. So aggregate demand overall remains unchanged, and there is so the only effect that we get is workers' consumption. The only effect is a one-off reduction in workers' consumption. So most of the simulation that we conduct is actually by testing what happens in the model if there is a slowdown in the low carbon transition that is caused by a negative shock to the green share of energy investment. What we mean by a negative shock to the green share of energy investment is some kind of policy option, some kind of drill, baby drill kind of shock. So what happens is that, well, quite clearly, the first impact is that greenhouse gas emissions increase. Then higher emission will adversely affect the macroeconomy, will negatively affect investment in the non-energy sector, and well, so a negative shock to the green share of energy investment will then transmit to the macroeconomy. So what we do in the simulation analysis is to compare three policy scenarios against the baseline to answer the question of, well, how can different kind of fiscal policies alter the effectiveness and environmental outcomes of a delayed energy transition. So the first kind of fiscal policy that we look at is an increase in is a sensitivity analysis of what happens in the model if we change the tax rate on workers' income. So if there is an increase in the tax rate, so the baseline is the orange line, orange red, and if there is the increase in the tax rate on workers' income, is associated with the yellow line. So there is a negative shock to the green investment share. Emissions increase. This is the flow of emissions. This is the carbon intensity of the production process. We get clearly an increase in both variable quarters. So the simulation is done for 50 quarters. Yeah, I didn't mention anything on the calibration. The calibration is the model is roughly calibrated. Is calibrated to roughly match some empirical moments in the U.S. business cycle, the U.S. business cycle quarterly. So an increase in the higher tax rate of on workers' income mitigates the negative shock of the green investment share clearly, because if we tax more workers, then the government will have more money to finance the transition. And the same actually applies for rentiers, with the difference that if we tax rentiers more than we tax workers, we get fiscal multipliers that are higher. So the negative shock is smaller. Progressive taxation in the model will allow to have higher fiscal multipliers when we tax rentiers, for the reason that I mentioned before, because rentiers have a lower propensity to consume compared to the government. The government has a higher propensity to spend than rentiers to consume. Last, this parameter P alpha G captures the effectiveness of the government spending to foster low carbon transition. And clearly, if there is when we have a negative shock to the green energy investment share, higher effectiveness of government spending, let's say a more committed more committed government that is more willing to the transition, this will reduce the negative effects of the shock on both aggregate demand, production, and also on the transition, on the low carbon transition. So in the paper, we also conduct a global sensitivity analysis of the entire model, and we show that the model is quite sensible to changes in the investment parameters, which I'll say is also quite reasonable given that our focus is on business cycles. Over the business cycle, the investment channel is the one that is more sensible to shift the cycle. What we show in the paper and is that first, a balanced progressive taxation strategy will enable the government to allocate more resources to mitigation strategies, and this will accelerate the transition to net zero emissions. We look at the financing mechanism for the transition under the assumption that government runs a balanced budget. So we look at who finances the transition, so who bears the cost of the transition. And this clearly is a question that ultimately hinges on the political economy, on political economy considerations. However, on the economic side, the model shows that if we tax less the rentiers, we'll have rebound effects. If we reduce the tax rate on rentiers, emissions will increase because rentiers will consume more. Conversely, progressive taxation that in the model is framed as taxing rentiers more heavily than wage earners will allow the government to allocate more resources to mitigation strategies, and this will accelerate the transition to net zero. So a progressive taxation strategy avoids scenarios that will be more difficult to be avoided if we only finance the transition by taxing workers. Broadly speaking, the model tries to emphasize how structural policy interventions could address both inequality and ecological sustainability. I'm going to stop here. I have the balance sheet and transaction flow models.
Thank you, Ettore, for your contribution and congrats on your publication. Since it's published, I'll be quick. I have a few simple questions and comments that might help you if you present it again or if you develop further your model. You start out your paper and also your presentation with the literature gap and your contribution. And what I would love to see a bit more is the main motivation for why you study it. Why is it relevant? What data there is? What discussion is? What is unsettled in like really what is unsettled in the debate of this? So why is it relevant? Really highlighting why is this so important to study? And from this, then it will be very natural to underline why your model is very suitable to study this kind of question. So I think this could be very helpful. What else? I've taken a lot of notes. And then the framework contains many elements, and one of them you're highlighting is the distributive dimension. There, I was a bit wondering how the channels are, or what kind of distribution you're looking into. So whatever concepts you're using, maybe inequality, explain what sort of inequality there is in the model, what you're really studying. Is it income, is it wealth, or is it post-tax, pre-tax? The same with, you're saying, can the low carbon transition be achieved without degrowth? What in your model would, where do I see it? What is the degrowth in your model? Where do I see it in the simulation results? And maybe it's just because it's a bit more, less usual to see all the impulse response functions to present it in that way for the ESG model. Maybe this is just much more what they're used to, but then explain maybe for this kind of modelers what is happening in the model, what we could see there. Anything else? Yeah, related to this was maybe you mentioned it very briefly about the calibration also there, what kind of data you're using, also the distributive data there is on the US and all of this. just as suggestion for your next extension. Thank you.
Yeah, I think that one gap in the literature is the focus on more business cycle frequencies. Like, as I briefly mentioned, there is evidence, extensive evidence that the transition is not only a long-term, the economic effects of the low carbon transition